go ahead and start today by looking at our bell work. So how bell work works in my class, it is not a grade, it's not something that you turn in, but it is to your benefit to do because you could see it on a test or a quiz. So for bell work, all you need is a piece of notebook paper. Just a plain piece of notebook paper will do. And we're going to review what we did on Friday, which was simplifying expressions with algebra review. So let's go ahead and simplify this first expression. Remember we talked about how to simplify expressions? We use the acronym PIMDUS. And if you want, you can pause this video. Since you can see the question, pause the video, do it yourself, and then play the video back and check and see how you did on it. But let's go ahead and simplify this. First thing I'm going to do is work on the inside of the parentheses first. So we always want to work on the inside and then work our way out. 2 minus 8 is negative 6 squared minus 31. I'm going to leave my brackets and my little squiggly lines, the set bars, all the same because I'm not done with them yet. Next step, minus 5 minus squiggly bar 4 minus 6. Exponents on the inside, negative 6 squared is 36. And squiggly bracket. Next step, let's keep going on the inside of those parentheses because I'm not done with them yet. 4 minus 6. The inside here, which I'll highlight, 36 minus 31, that goes down to 5. Squiggly bar. Next step, now we're done with the brackets, let's go ahead and work our way out. So the next thing I see is these squiggly bars. Let's simplify everything inside there. Minus 4, 6 times 5, that's our next step with the multiplication. 6 times 5 is 30. All right, keep working on the inside of those squiggly brackets, that's a negative 5. Minus 4 minus 30 is negative 26. And last step, this double negative changes to a positive. Negative 5 plus 26 is positive 21. That is our final answer, fully simplified. I do like to see work, so I can see maybe if you made a mistake, like if we would have made a mistake up here, then I would have been able to see if your work was correct as you kept going till the end. So I like to see work, so please show your work on these problems. The other thing we talked about on Friday was evaluating expressions. We talked about evaluate meant to substitute. So we're going to take what we know and substitute it into our expression. 4/3, that can stay the same. Pi, they told us to put this 22 over 7. So I'm just going to put that in place. And then the next one, they told us R was 3. So in place of R, I'm going to put a 3. And that is our answer. You are more than welcome to type that into the calculator, but since we're trying to do this without the calculator, my goal here was just to make sure you knew what evaluate meant, and that's what it means, substitute in, so you can stop there. Okay, so let's go ahead and take a look at what we're doing today in our lesson video. Today we're going to discuss adding, subtracting, multiplying polynomials. We are still in chapter R. We're in section 3 though, because we're reviewing your algebra skills. Now would be a good time though to go ahead and pause the video and get out either a piece of paper for your notes, or you can use the notes I posted online. I posted a copy of my notes as well as a fill-in-the-blank version, so you can print those off. Really good to follow along with me as I go through our lesson today. So since we're talking about polynomials, let's go ahead and define first what a polynomial is. A polynomial can have constants, variables, and exponents, but never division, that's your first blank on your notes, division by variables, and no fractional exponents. No fractional exponents. Let's go ahead and use this definition we just talked about to decide whether these examples are polynomials or not. So as we look at A, 3x cubed minus 2x squared plus 8x minus 9. Well, I don't see any division here, so the first one's good. And there's no fractional exponents because all of these exponents are whole numbers. So this is a yes. This is a polynomial. Fits our definition. Good job. Next one, B, 2 minus 6 over x squared. This one clearly has the division by exponent, by variables, because it's got a variable in the denominator, which means that this is a no. This is not a polynomial because of that variable in the denominator. C, let's see, I've got negative 4x squared plus 6 root of x minus 9. So this looks fine when we first look at it, but the root of x, recall from your algebra classes, the root of x is the same thing as x to the 1/2 power. As we look at that, notice that it is a fractional exponent, which means this is a no. This is a no, not a polynomial because of that fractional exponent. And last one, D, 8p cubed plus 9 absolute value of p. Absolute value bars, our definition didn't say anything about that causing a problem. There's no division and there is no fractional exponent. So this is a yes. It is a polynomial. Okay, let's go ahead and try some operations with these. When we are adding and subtracting polynomials, that is called combining like terms. Recall from your algebra classes, like terms have the same variable or letter. So those must be the same, and they must be raised to the same power or exponent. So the same variable, same power, we can combine them together. So let's do example E. As we go through these examples, it's also a good idea for you to pause the video and try them on your own once you feel comfortable, then play this video back and see how you did on those. So on E, see, we're looking for things that have the same variable raised to the same power. Well, these both have p to the 7th, so I can combine them. Negative 8 plus 2 is negative 6 p to the 7th. Those are like terms. Next one, p to the 4th. Here and p to the 4th in the next one, I can combine those together. Negative 4 plus 6 is positive 2 p to the 4th. Okay? Then I see p squared. Well, I don't have a p squared to combine over in this other parenthesis, so I'm just going to drop that straight down, p squared. Same thing with 2p. So I look across my expression, I don't see anything that just has a p, so I'm just going to leave 2p where it is. And then minus 5, my constant, there's nothing else that does not have a letter with it, so I'm just going to drop down that minus 5 there as well. And that is our simplified polynomial. Okay, so this next problem I wanted to do with you guys because it's very similar to what's on your homework and it's kind of tricky in the wording. So subtract this expression, so the red expression, from the green expression. Okay, so we're taking the red and pulling it out from the green. So I'm going to write the green first, plus 3x cubed y minus 6. And then I'm going to subtract the red. So just be careful on your wording on this problem. We're taking the green minus the red. And now I'm just going to combine like terms. Negative 7, let's see, I've got x to the 5th y squared, x to the 5th y squared. Negative 7 minus 9, make sure you subtract every term in the red. So we get negative 16, x to the 5th y squared. Okay, now I'm going to move on to my x cubed y and x cubed y. 3 minus negative 5, minus a negative makes that a positive. So 3 plus 5 is 8, x cubed y. Then next, I'm going to look at my 4x, and I've got just an x there, but I have to subtract it. So that becomes a minus 4x. Then my constants, I can combine those. Negative 6 minus negative 3, which is like adding 3, makes this a negative 3. And that is our fully simplified polynomial. We know it's simplified because we can't do anything else. We can't combine anything. We can't add or subtract any terms together. Alrighty, let's try one other one that's a little bit more complicated just because we've got fractions, but we can do it. We're mathematicians, we can handle fractions. So let's go ahead and start by seeing there's really no like terms I can combine yet, but let's go ahead and simplify and see if we can. So using what we know about PEMDAS, remember P stands for parentheses, very good. So we're going to take 4 and distribute it through my parentheses. 32 minus 20x, close my bracket, plus I'm actually going to go ahead and distribute the 2/3 here as well, just to get rid of the other set of parentheses. 2 times 6 is 12, divided by 3 is 4, x squared, minus 2 times 9 is 18, divided by 3 is 6, x. Remember multiplying fractions? You multiply the top and you multiply the bottom, just straight across. Okay, we're almost done. We need to get rid of these brackets, and how I'm going to do that is I'm going to distribute my negative on through all of those parentheses, or brackets, everything inside the brackets. So negative 3x squared minus 32 plus 20x. And now my brackets are gone. So my last step is going to be combine like terms. And I like to start with the highest exponent first, just so that this is written in standard form when I simplify it. Negative 3 plus 4 is 1x squared. Then combine my x's. It looks like I've got 20x and minus 6x. 20 minus 6 is 14x. Combine those together. And last is my constants. 13 minus 32. 13 minus 32, if we get negative 19, yes. Had to think a minute. Negative 19. Okay, now that we've done an example with adding and subtracting polynomials, let's do some with multiplying. How we multiply polynomials is using what's known as the distributive property. You learned about this in middle school. The distributive property allows us to multiply two polynomials together. So the way we multiply these terms, 4x plus 5 and 9x minus 7, so there was a special acronym that you can use to multiply these, and it's called F-O-I and L, FOIL. And that's what we're going to do, FOIL these two terms together. So first, F stands for first, so I'm going to multiply the first terms together. 4x times 9x is 36x squared. Then O stands for outer, so 4x and negative 7. Multiply those, negative 28x. I stands for inner, so my two inner terms, 5 times 9x is 45x. And then last is 5 and negative 7. 5 and negative 7 make negative 35. When I multiply those together, now I'm just going to combine like terms, my last step. 36x squared, that can't combine with anything because there's nothing else that has a 36. It has an x squared with it. Negative 28 plus 45 is 17x. And then drop down my minus 35 because that does not combine with anything either. That's our simplified polynomial expression. Let's try another one. So this next one is the same kind of setup, two binomials. So we're going to use FOIL again. First, outer, inner, last. The only thing we have to be worried about is these are fractions. So you have to pull back your elementary knowledge of fractions and use that here to multiply. So multiply the top, multiply the bottom to get our numbers. So 2/5 times 2 over 1. I just put a 1 just to make multiplying a little bit easier for us. 2 times 2 is 4. 5 times 1 is 5. X squared. First term done. Outer term. 2/5 x times negative 1/2. 2 times negative 1 is negative 2. 5 times 2 is 10. Tack on my x. Inner terms, negative 4 times 2 is negative 8. Tack on my x. And last, negative 4 times negative 1/2 is positive 4 over 2, which makes 2. So I just simplified that, 4/2 to make 2. Now we just combine like terms, just like we did on the last problem. 4/5 x squared. Notice I've got two x's here, so those can combine together. The only issue is that you can only combine fractions, like add or subtract them, when they have the same denominator. So I've got to make these have the same bottom denominator. And I'm going to do that by just multiplying. 10 times 1 is 10. Well, this already has a 10 to start with, so I'm going to leave the 2 on top. Since I'm changing this denominator to 10 by multiplying it by 10, I'm going to multiply the top by 10 to get 80. And I can keep my plus 2 because that does not combine with anything. So we can leave that. And last step, just combine like terms, continuing that process till we're done. Negative 2 minus 80 is negative 82. I'm going to keep that in green so we know where that comes from. Negative 82x over 10, and just bring down the plus 2. Okay, you can stop there because that's all really we can combine together. Since it is a fraction, you could reduce, so I'm going to draw an arrow. And you could keep the 4/5 x squared. That would stay the same. The plus 2 would also stay the same. You can reduce the green fraction, though, to negative 41 over 5x. You're more than welcome to reduce that. So you can leave it like this term, or you can put it in the simplified form. I would accept either version. Okay, on this next problem, this is very similar to what we just did. The only difference, which is why I wanted to do this problem with you, is the squared up here. Remember, whenever we have something raised to a power, that means to multiply. So I'm going to multiply it twice and write it twice. So because this is a 2, I write it twice. Now I'm just going to FOIL. If I were you at home, I would pause the video right now and see if I could do this problem on my own. See how I did, and then you can play it back and see if your work matches mine. Let's go ahead and simplify this, though, using FOIL. 2/3 times 2/3, remember first, 4/9 x squared. X times x is x squared. Next, the outer terms. 2/3 times negative 4 is negative 8/3 x. Then I'm going to do my two inner terms. Negative 4 times 2 is negative 8/3 x. And then I'm going to do my last term. Negative 4 times negative 4 is 16. Now our last step is just combining those like terms together. 4/9 x squared, that can't reduce, so I'm just going to leave it. And it can't combine with anything, so I'm just going to leave it where it is. Negative 8/3 and negative 8/3, those combine because they already have the same denominator to make negative 16/3 x. And then last is the plus 16. That can't combine with anything else. And that is it on that.